Hello everyone, this is Y. Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering College. So today I am going to discuss about the probability theory. Probability theory. So introduction to the probability theory. So probability, the name itself, ability to do the problems on critical thinking, on learning basis, on any way. So you can do the practicals, you can do the problems on ability based wise. So we will see. So how the probability problems will come and how we are going to solve the probability problems, right? So see here the introduction to the probability. So introduction to the probability. So generally we are going to know about the probability with some concepts. We need to know some concepts before going to learn about the probability. So before going to know about probability, we must know some concept as follows. So what are the concepts? So first concept, an experiment. So what is meant by an experiment exactly? So generally an experiment is a practical, right? An experiment is a practical. We can expect a result from the practical. We can expect that result from a practical. So like the way you can mention here, an experiment is defined as a process. An experiment is defined as a process for which its result is well defined. Its result is well defined. That means whether the result is success or failure. Whether the result is success or failure. You should understand. So an experiment is said to be a process in which the result is well defined, right? And next, deterministic experiments. Deterministic experiment. The name itself, deterministic experiment, is an experiment whose outcomes can be predicted. Whose outcomes can be predicted with certain under ideal conditions. With certain conditions under ideal conditions. So we can expect the result, whether it is success or whether it is a failure. We can expect the result. So the expecting result from the experiment is called as a deterministic experiment. Deterministic experiment. And a random experiment. So a random experiment is nothing but non-deterministic experiment. A random experiment is nothing but non-deterministic experiment. That means you are not going to be predicted whether this particular result is evidenced, whether this particular result is outputted or not. So a random experiment is non-deterministic experiment is an experiment whose all possible outcomes are known in advance, but not sure, whose each outcome is not possible to predict in advance. So is not going to predict that advance, and it can be repeated under identical conditions, So among these all the values, among these all the scenarios, you can say that it is a non-deterministic experiment. Non-deterministic experiment, that is nothing but random experiment. So we'll get the outputs as random wise and that cannot be predicted. We'll get the result as random wise and that cannot be predicted. So that is nothing but random experiment. So experiment is nothing but a practical, whether that outcomes are expected or not. So the result will give. But if it is identified whether that particular result is evidenced or not, so that is nothing but deterministic experiment and non-deterministic experiment. So these two types are experiment types. And next, so simple event, or you can say that elementary event, or you can say that sample point. You can say that simple event or elementary event or sample point. You can take any of the term here from this. So sample point or simple event or elementary event. So it is the most basic possible outcome of a random experiment and it cannot be decomposed further. So that is nothing but if you are taking a coin to toss, the expected result is either head or toss. So the result is nothing but simple event. The result is nothing but simple event, whether that is head or tail, whatever it may be. The result is nothing but simple event. So you can say that simple event or elementary event or sample point is the most basic possible outcome of a random experiment, and it cannot be decomposed or divided, right? So and next, sample space. So sample space is nothing but set of all possible outcomes. Means if you do this practical, you will get the outputs as much as chances. So you will get all these outputs, but may not be confirmed these outputs. So that outcomes are nothing but that outcomes of the random experiment is nothing but sample space. So doing the practical is okay, but the outcome, the output is what? Sample space. The output is what? Sample space. So set of all possible outcomes, of that random experiment is said to be sample space. So that possible outcomes are nothing but, suppose you can take any of elementary event. So example you can take, if your die is rolled, then you will get the chances 1, 2, 3, 4, 5, 6. So these are all you can say that a sample space. So rolling the die is a simple event. And you will get all the values is nothing but sample space. So sample space for the dice is what? S equals to 1, 2, 3, 4, 5, 6. So sample space for the dice equals to 1, 2, 3, 4, 5, 6. After that, you will not have any numbers, right? So that is one. And if a coin is tossed, so you'll take one coin, 1 rupee coin or 2 rupee coin. So if you toss that coin, so you will get either head or tail. So definitely the sample space is only head or tail. So that means for this coin tossing, you will have two number of sample space, and if you roll a dice, you will get 6 as a sample space. So suppose if we toss a coin until a head is obtained. See, obtaining head is not an easy or not an difficult also, because if you toss one time, then the first time you will get head, but if you toss multiple times also, you may not get head, right? So we toss a coin until a head is obtained. We cannot say in advance how many tosses will be required. Yes, definitely we are not going to say. We are not able to say also, because if and only if it is having some tails for the couple of types, and so the sample space is what? Say S equals to head one time, or tail head one time, or tail head one time. Like the way you can have a number of ways. So if you can toss a coin for the first time, then you may get or you may not be get. So for the second time, you may get or you may not be get. So like the way you can assume that number of times we can toss a coin is an infinite set. That means based on the scenario, we are going to obtain the head, right? So infinite set we are saying. So that is the way you can take an examples. So this is nothing but sample space of a coin and a sample space of your dice, right? So and we'll see here. So we can have number of countable and number of uncountable. So number of sample points or elementary events in a sample space. So number of sample points are elementary events in a sample space. So you can say sample space is equals to for the dice 1, 2, 3, 4, 5, 6. You can have, right? So a number of sample space you can have 1, 2, 3, 4. In that if you roll a dice for the first time, then you will get 1 or 2 or 3 or 4 or 5 or 6, maybe whatever the number you will come. So that is nothing but countable number of sample points. If you can count the number of, that means you can give the result of that number of points, then there is nothing but countable number of sample points. Suppose uncountable means, so you can see this one only. Until we get head, we need to toss a coin. Multiple times. So that is nothing but uncountable number of sample points. Uncountable number of sample points. So finite number of sample points contains only the countable numbers. So that is nothing but if you roll a dice 1 or 2 or 3 or 4 or 5 or 6 you may get. So that is the finite number of sample space is equals to 1, 2, 3, 4, 5, 6 you will get. And countable infinite number of sample space. So in the previous example only, it's itself only. So until we get head, we need to toss a coin. We need to toss a coin multiple times. We need to toss a coin multiple times. But 100th time or 200th time also, you may get a head. So that is nothing but countably infinite number of sample space. Countably infinite number of sample space. So this is the way you can understand. And next one is types of events. So types of events. So let us now define some of the important types of events. So which are used to frequently in this unit. So certain event or sure event. Certain event or sure event. And second one is complementary event. Complementary event. And third one is mutual inclusive event. Mutually inclusive event. And next one equally likely events. Equally likely events. Next impossible event. Impossible event. And next one is mutual exclusive event. Mutually exclusive events. And next exhaustive events. Exhaustive events. And last independent events. Independent events defined after learning the concepts of probability. So these are all some different types of events that occur in the probability. So different types of events that occur in the probability. So we will see the different types of events. So when the sample space is finite, any subset of the sample space is an event. Any subset of the sample space is an event. That means the result you will get from all these chances is nothing but a subset. That subset of the sample space is an event. So that is all elements of power set P of S of the sample space are defined as events. So we can have a number of elements is finite, and from these all the finite elements you will get a subset of the result. That subset is nothing but events. So that is what we mentioned here. All elements of the power set P of S. All the elements of the power set P of S of the sample space. So sample space equals to S equals to 1, 2, 3, 4, 5, 6, 7, 8. You may have. So from this, the all elements of power set. So power set P of S is an event from event for this sample space. Event for this sample space. So that is the way you can mention here. And similarly, you can say an event is a collection of sample points. An event is a collection of sample points or elementary events. Elementary events. So you can say that collection of sample points or elementary events. So the sample space S is called sure event or certain event. If and only if that sample space contains elements. Then that event is said to be sure event or certain event. Similarly, the null set pi in S is called impossible event. So impossible event, that is nothing but pi of S equals to no elements are there. So then it is said to be impossible event. And for every event A, there corresponds another event is called a complement. So corresponding one event, the another event existed. So then it is said to be complementary event to the A. So corresponding to the A event, another event existed. So that event is nothing but complementary event. So A power C and A complement also you can say that. So A complement, the complementary event to A, it is also called the event not A. That means that is not occurred. So that is a complement to A. Next, coming to this probability definition. So probability of an event refers to the probability of an event refers to the likelihood that the event will occur. Likelihood that the event will occur. The event is presented, then you can say that it is a probability of that sample space. You can say that it is a probability of that sample space. So and expressed as a number between 0 and 1. And expressed it as a number between 0 and 1. So you can say that the probability of an event refers to the likelihood. So the likelihood is nothing but the same or the favorable elements or favorable thing that the event will occur, and it has expressed as a number between 0 and 1. Number between 0 and 1. So probability of event A is represented by P of A, and if it is related to the A, if it is related to the sample space P of S, you can take it as P of S equals to, you can take it as. So net, let S be the sample space associated with a random experiment. We know that experiment and random experiment, right? So and A be an event, let n of S and n of A, n of S and n of A be the number of elements of S and A respectively. Number of elements with respect to the S and small sample space and A, number of events respectively. So then the probability of the event A is defined as number of cases favorable to the A, number of cases favorable to the A, and number of cases in sample space, total number of cases in sample space, total number of cases in sample space. So simply you can say that probability of sample space equals to the number of favorable cases of the sample space divided by total number of sample space. That is nothing but P of S equals to number of favorable cases by total number of sample space elements. So that is nothing but a probability. So if you want to find the probability of any sample space or any event, so you should write this formula. So what is that? So probability of an event A, equals to number of cases favorable to the event A divided by total number of exhaustive number of cases in S. So that is nothing but probability. In other way, you can say that like this: probability of sample space equals to number of favorable cases divided by total number of sample spaces. So like the way you can mention it. So this is the way you can define the probability. Simply the probability of an event refers to the likelihood that the event will occur in the sample space. So then you can write the formula probability of S equals to, or probability of A equals to, you can write this less number of favorable cases divided by total number of sample space elements. So like the way you can write. And next one, if you see these examples, so if a coin is tossed 3 times, then what is the probability that it lands on heads exactly one time? If you do the task, means you can toss a coin for the first time, you may get head or toss, and second time you may get head or toss. Similarly, you can third time you may get head or toss. So total number of possible outcomes. So we need to get sample space equals to 2. That means either head or either tail. So power set of this sample space 2 power 3 times means, so 2 power 3, you will get chances 8. You will get chances 8 possible outcomes. 8 possible outcomes you may get here. So if you toss a coin 3 times, there are total of 8 possible outcomes. So that possible outcomes are like you can write. So for the first time you may get head, and for the second time you may get head, and third time also you may get head. Similarly, for the first time you may get head, second time also you may get head, and third time you may get tail. and third time, so you may get a head, you may get a tail, and you may get a head. And the fourth time you may get a tail, and you may get a head. And fifth time you may get a head and a tail and a tail. And the sixth time you may get a tail, head, and a tail. And you may, seventh time you may get tail, head. And last you may get total tail. So among these all 8 possible outcomes, what is the exact, we need to land some heads exactly one time. So what are the outcomes? Will have only one head exactly, means you can see this is exactly one head, and this is also exactly one head, and this is also exactly one head, right? So total 3 cases we have got exact one head, and remaining all the cases are we may have multiple times of head. So see here, from question we have 3 exactly one head. So their head tossed us, that means head tossed us this one, in this case, and in this case, and in this case. These 3 cases, 3 have exactly one head. In these 3 cases we have exactly one head. So therefore the probability of that 3 flips a coin, so 3 flips a coin will produce exactly one head is, so what is the formula? Probability of sample space equals to number of favorable cases by total number of sample space. So P of S equals to number of heads we got exactly 3 times by total number of possible outcomes, what? 8. So that 3 by 8. So 3 by 8 is nothing but 0.375. So this is the way you are getting values for the probability. So there is no units for the probability, you can write directly. So this is the way you can do the example. And similarly you can see another example here. So in this example we'll have 10 marbles, we'll have total 10 marbles, and among the 10 marbles we'll have 2 red and 3 green and 5 blue, right? So total 2 red and next 3 green and next 5 blue, right? So 5 blue. So find the probability of selecting a green. Find the probability of selecting a green. So we need to find out. So total number of elements is what? So total 10 marbles, right? So total 10 marbles, nothing but S equals to 10. You can write directly. So 1, 2, 3, or else you can write directly 10, right? And solution. See here. So green are only 3. So we need to have green. Green is only 3. So number of favorable cases are what? Number of favorable cases are only 3, and total number of cases, total number of elements are what? Number of S equals total number 10. So total number is 10. So taking the greens are only 3, and the total number of elements are 10. So the probability of selecting the green is what? So probability of green equals to, so number of favorable cases by total number. So number of favorable cases is nothing but selecting the green. So total the selecting the green is what? 3, and the total number of elements is what? 10. Total number of elements 10. So P of G equals to 3 by 10. That is nothing but 0.3. You can write 0.3 is the probability of selecting a green from 10 marbles. So like the way you can have some problems. And next we'll see the probability of an union. So we know that a set contains the values. We know that a set contains some values, right? And operations on that set or union. Intersection are most preferable. Union and intersection most preferable, and complement also there. So from this problem, probability of union. So probability of union is nothing but we are going to mix all the elements. With duplication not existed. with duplication not existed. So we'll see. So event A contains 1, 2 elements, and the event B contains 2, 3 elements, and the event C contains 3, 4 elements. Event C contains 3, 4 elements. So from these events, what they given, the probability of the union of two events, the probability that either the both events occur. So find the probability of union of event A and event B. Event A and event B. So we need to find out what union of event A and event B. So this is event A and this is event B. So union of, that is nothing but P of A union B. P of A union B is nothing but how many elements you can have. So 1, 2 from P of A and 2, 3 P of B. P of B, right? So union operation. So total what? 1, 2, 3. 1, 2, 3 is the probability P of A union B. So from this, what you need to get? So probability of union of A and B, we can have, if you mix P of A union B, you will have the value as 1, 2, 3 only, because the union operation does not hold the duplicate values, so that's why you are not going to enter again the two value, so the values are 1, 2, 3 only. P of A union B equals to 1, 2, 3. Now the probability of the A union B is what? So probability of P of A union B is what? So total number of favorable cases from union B is what? 3, and the total number of elements from these two sets. Total number of elements from these two sets what? 4. So that 3 by 4, that equals to 0.75. 0.75 you need to get. So the probability of union, you can do it only union operation. If in case the probability of intersection, you can take only the common elements. Common elements from the sets, from the events. Suppose you can see here probability of intersection. See here. So intersection symbol indicates like this intersection. So P of A intersection B you need to find out. P of A intersection B we need to find out. So first P of A set is what? 1, 2, and B set is what? 2, 3. 2, 3, right? So intersection A intersection B is nothing but the common elements from the event A and event B. So you need to take the common element from event A and event B. The value is what? 2. The value is what? 2. So A intersection B is 2. Now what we need to do? Find the probability of intersection. Find the probability of intersection equals to, so number of favorable cases by total number of elements in the events. So number of favorable cases is what? So only one you need to write. So only 2 is there, so only 1 you need to write, and total number of elements in these two events are nothing but 4. Total number of elements in these two events is nothing but 4. So 1 by 4 you can write it as 0.25. So this is the way you can do the problems on probability. And see here another one example. So what is the probability of rolling a 5 when dice is rolled? So when dice is rolled, you will get any of these numbers. But you will get only 5. So what is the probability? So number of ways it can occur only one time. So you can write it directly. And total number of possible outcomes are 6. So the probability of rolling a particular number when a dice is rolled. So obviously only one chance, only one you will get. So 1 by total number of value 6. So probability of dice equals to only one time you will get the 5. So you can write 1 by total number of outcomes are 6. So total number of outcomes are 6. So like the way you can do the probability. and compound probability. The next one is what? Compound probability. So compound probability is when the problem statements asks for the likelihood of the occurrence of more than one outcome. So if the result is existed with more than one outcomes, if the result is existed with more than one outcomes, then you can say that it is a compound probability. Then you can say that it is a compound probability. You can say that it is a compound probability. So the compound probability formula is what? P of A or B is nothing but A union B, you can write. P of A or B is nothing but P of A union B, you can write. And formula P of A plus P of B plus B for P of B minus P of A intersection B. P of A intersection B. So P of A, P of B and P of A intersection B. So this is nothing but compound probability of A comma B events. We can say that if A comma B are the events, then the probability, compound probability of A comma B is P of A union B equals to P of A plus P of B minus P of A intersection B. P of A plus P of B minus P of A intersection B. So this is nothing but compound probability. So normal probability is what? Normal probability of event A is what? Number of favorable cases by number of total sample elements, number of total sample events. That is nothing but probability. But compound probability is nothing but what? When more than one outcomes are existed in that event, when more than one outcomes are existed in the event, so that P of A union B equals to P of A union B equals to, so P of A plus P of B minus P of A intersection B. P of A union B equals to P of A plus P of B minus P of A intersection B. So this is the compound probability formula and this is normal probability formula. Right. So let us take some examples here. So what is the probability of getting 2 RFI? 2 RFI when a dice is rolled. When a dice is rolled. If you roll a dice, then you will have the possible outcomes are total 6. So among that all the 6, you may get either 2 or either 5. You may get either 2 or either 5. So what is the probability of getting 2 or 5 from when dice is rolled? So we need to see. So taking the individual probabilities of each number, so getting a 2 is 1 by 6. 1 by 6. So total possible outcomes are what? 1, 2, 3, 4, 5, 6. These are the total probabilities outcomes, right? Total probability outcomes. But as per the question, we are getting what? Either 2 or 5. Either 2 or 5. So P of 2 equals to P of 2. How many cases we are getting? Only one time. So P of 2 equals to 1. And next P of 5 equals to P of 5 equals to only one time. P of 5 equals to only one time. So P of 2 and P of 5. And P of A intersection B is always 0 because they are independent events. They are independent events. So 2 is separate and 5 is separate. They are not dependent and they are not mutually exclusive events. So you can say that P of A intersection B is to be 0. So now we know that P of 2 value and P of 5 value. So we need to substitute those values in P of A union B. That is nothing but 2 union 5. P of 2 union 5 you can substitute. So what is the formula? P of 2 plus P of 5 minus P of 2 intersection 5. P of 2 union 5 equals to P of 2 plus P of 5 minus P of 2 intersection 5. P of 2 intersection 5. So what we will get here? P of 2 is nothing but only 1. That means 1 by 6. 1 by 6 plus P of P of 5 is nothing but only 1 by 6 and P of 2 intersection 5 is nothing but 0. So what we will get? 1 plus 1 by 6, that is nothing but 2 by 6. That is nothing but 2 by 6. That is nothing but 1 by 3. 1 by 3. So like the way you will get the values from the compound probability. You will get the values from compound probability. Right? See, when we'll talk about the problems on these cards, 52 playing cards. When we'll do the problems on these cards, you need to know about this all the cards. You need to know about this all the cards. So a set of 52 playing cards. So definitely you will get all the different types of questions on these 52 playing cards. So total 52 playing cards are there, and that 13 of each shoot. 13 of each shoot. So one is clubs, and one is diamonds, and one is hearts, and one is spades. So total 4 types are there. So each and every type contains 13 cards. Each and every type contains 13 playing cards. So among those 13 playing cards, you will have 10 cards normal, and one jack, one queen, and one king. So you can see here. So these are all 10 normal cards. The next one jack, one queen, and one king. So 3 cards. So for the clubs, you will have 10 plus 3 cards, and for the diamonds, you will have 10 plus 3 cards. And similarly, for hearts, you may have 10 plus 3 cards. And for the spades, you may have 10 plus 3 cards. So total, you can see total 52 cards. Total 52 cards. So with this 52 cards, the first type is clubs, 13 cards. And second type is diamonds. And third type is hearts. And the fourth type is spades. So why we are going to talk about this all means, so we may have a lot of problems on playing cards. We may have a lot of problems and lot of probability definitions, a lot of probability definitions on these playing cards. So that's why we have to talk about this one. We have to talk about this one. So see here, consider the example of finding the probability of selecting a black card or a 6 from a deck of 52 cards. So they are given the total 52 cards. Among that all the 52 cards, you can draw a black card. So the probability is to draw a black card or a 6 from the deck of 52 cards. So you are taking the black card as well as 6 card. So taking the black card is okay, and that black card is maybe the 6. The black card is also a 6. So that is what we are going to understand. And see, we need to find out P of B union 6. So we are going to find out P of B or 6. We need to find out, right? So P of B or 6. So see here, probability of selecting a black card. So total black cards are, how many black cards are here? So see here, this is all 10 black cards, and this is all 10 black cards, and from here 3 black cards, and here from 3 black cards. Total 13 black cards, and here 13 black cards. Total 26 black cards are there. Total 26 black cards are there. So probability of selecting black card. Probability of selecting black card is what? 26. So among all the total cards are 52. Right. So probability of selecting a black card is 26, and all the cards are 52. So total probability of selecting black card is 26 by 52. Right. And similarly, probability of selecting a 6. Selecting a 6. See, from the deck of cards, how many 6s are there? So 1 6, and here 1 6, right? Here 1 6, and here also 1 6, and here also 1 6, right? So from this all the 6s, so probability of selecting 6 is what? Total 4 by 52. 4 by 52 means 4 cards are number of 6, 4 cards are number 6, and all deck of cards 52. So probability of selecting 6 is 4 by 52, and the probability of selecting black card is 26 by 52, right? So now probability of selecting both a black card and a 6. So both a black card, and we are taking the 6 as a black card. So how many number of black cards are having 6, right? See here. So only 6 black card, and here 6 black card. So only 2 we are having. So P of A intersection B. P of A intersection B is nothing but P of B intersection 6 equals to only 2. So that you can write 2 by 52. 2 by 52. Right. So now the compound probability formula is what? P of B union 6 equals to P of B plus P of 6 minus P of B intersection 6. P P of B plus P of 6 minus P of B intersection 6. P of B intersection 6. So P of B value is what? 26 by, you can see here 26 by 52. Right, P of 6 is what? P of 6 is 4 by 52 minus P of B intersection 6. P of B intersection 6 is nothing but taking the black odd, and it should be the 6 value, and it's the 6 value. So 2 by 52. So total 26 by 52 plus 4 by 52 minus 2 by 52. So what is the value? You will get 28 by 52 final value. 28 by 52. So 28 by 52 is nothing but you can write 4 into 7. 4 7 is 28 and 4 13 is 52. So the probability value is 7 by 13. The probability value 7 by 13. The probability of finding, the probability of selecting a black card or 6 from a deck of cards equals to 7 by 13. So this is the way you will get the compound probability problems, right? So that is all probability, and so we need to follow some axioms to find the probability here. So for that axioms, see here, axiom 1 is what? For any event A, comma P of A greater than or equals to 0. So the event A should be, probability of event A should be greater than or equals to 0. It should be equals to greater than or equals to 0, but not less than 0. And second one is what? Probability of the sample space is P of S equals to 1. P of S equals to 1, it should come P of S equal to 1. And axiom 3, if A1, A2, A3 and all are disjoint sets, then P of A union A2 union P of A3 union up to P of AN. AN is nothing but nth term of that probability of event, nth time or nth event of probability of A. Then you can rewrite it as P of A1 plus P of A2 plus and P of A3. P of A1 plus P of A2 plus P of A3 plus. So these all the axioms, a list of axioms of the probability, and you can read them in another way. This is the probability of an event is a real number greater than or equals to 0. So this is what we mentioned here, the first one. So the probability of an event is real number greater than or equals to 0. Greater than or equals to 0. And axiom 2, the probability that at least one of all the possible outcomes of a process will occur is 1. At least one, that means P of S, the probability of sample space is equals to 1 at least. And axiom 3, if two events A and B are mutually exclusive, if two events A and B are mutually exclusive, then the probability of either A or B occurring is the probability of A occurring plus the probability of B occurring. So that is something but this one. So probability of either A or either B or either C, you can take it as a P of A plus P of B plus P of C. So like the way you can write it. So the probability of either A or B occurring is the probability of A occurring plus the probability of B occurring plus the probability of C occurring. Like the way you can consider that one. So this is the axioms of the probability. So these are the probabilities. Okay. So till now we have discussed about the definition of experiment, random experiment, non-deterministic experiments, and the event and the types of events, and the definition of probability, and the some problems on probability, and the compound probability and the compound probability problems, and the list of axioms of the probability. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.